Happy morning, dear students. Welcome back to the today's session. And this session, we are going to continue the discussion of mode when the data is in continuous series. In the previous session, already we have started, and we'll discuss one more example question to calculate mode when the data is in continuous form. Take down one more example question. The question number 2, mode for the continuous series. For the continuous series, and first example question already we have discussed in the previous class. Now example question 2. Compute the mode. Compute the mode for the following data. Now data is xf. X is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Then frequencies are 7, 11, 18, 12, 9, 6. These are the frequencies. Here, already we have discussed in the previous class. Here, to know the mode or to calculate the mode, we have two formulas. What are that? First, we need to use the formula to find out the mode class. The formula is model class or mode class equal to size of highest frequency. Size of highest frequency is the formula. Here the size of highest frequency in this all is 18 compared to other frequencies. 18 is the highest frequency. Then the size of 18 frequency will be the mode class. The size of 18 frequency will be the mode class. Then mode class equals to which is the corresponding of this 18, 30 to 40. Mode class is now 30 to 40. Again, after finding the modal class or mode class, again we need to find out what is the mode in between this 30 to 40. For that, we have one more formula to find out the exact mode. That is, mode equals to L plus D1 divided by D1 plus D2 into I. Got it? Here, D1 means, L means lower limit of the mode class. D1 means frequency of the mode class minus frequency preceding to the mode class. Next, same it will be D1. D2 means frequency of the mode class minus frequency succeeding to the mode class, or simply we can say D1 is equal to F0 minus F1. Here F0 means the mode class frequency. F0 means mode class frequency. F1 means frequency preceding to the mode class. Mode class frequency will be F0. Frequency preceding to the mode class will be F1. Frequency succeeding, it means frequency after the mode class will be called it as a F2. Got it? It should be very clear. Frequency of the mode class will be called as F0. Frequency before the mode class or previous to the mode class will be F1. Frequency after the mode class will be F2. Now D1 means frequency of a mode class minus frequency of a preceding to a mode class. Now F0 means 18, F1 means 11, 18 minus 11, 7. Next, D1 equals to 7. Got it? We obtained the D1 to obtain a formula. Or else here only you can write down D1 means 18 minus 11. Instead of that, we can make it clear here itself. D2 is equal to F0 minus F2. D2 means F0 minus F2. Here in D1 and D2, F0 is common. But in D1, we have to subtract F1. In D2, we have to subtract F0 with F2. Got it? Here, F0 means 18 and F2 is 12. 18 minus 12 will get 6. Then value of B2 is 6. Then easily we can apply to the formula. Got it? Then x lambda is equal to L. L means lower limit of the mode class. What is the lower limit of the mode class? 30 plus D1, how much we got it? 7. 7 divided by, again D1 means 7 plus D2 is how much? 6. 6 into I means size of class interval. Here what is the size of class interval? 30 to 40 means the 10 will be the class interval size. Formula is upper class limit minus lower class limit. 40 minus 30 will get 10. Okay, this is how to get the values in place of the formula. Then x lambda is equal to 30 plus 7 divided by 7 plus 6, 30 into 10. Next, x lambda is equal to 30 plus 7 divided by 30, 7.538 will get into 10. X lambda is equal to 30 plus 0.5 into 10, 5.38. Then answer will be 35.38. This is what the mode in between mode class. We will get exact mode by using this particular formula. I hope you understood now. Firstly, we need to find out the mode class. After finding the mode class, here we need to give frequency of the mode class as a F0, frequency preceding to the mode class as a F1, next to a F2. Then we need to find out D1 and D2 values and we can apply to a formula, and by simplifying this, will we get the answer of mode. Got it now? Then we'll discuss one more problem related to the mode only, because it's very important for the examination point of view. For the 4 months or 6 months. Continuous series usually they ask for 6 months. Let's discuss one more problem with the same format. Take example question 3, saying compute the mode for the following data. Then they will give data like this: voltage, here number of days. Here 240 into 2 226 to 230 and 230 to 236. And here number of days 15, 37, 86, 164 and 28. Got it? Now this data we need to arrange in the vertical rows. Yes. Then give it X for the voltage and F for the number of days. Okay. Here X means voltage and number of days means F. 14 to 18, to 18 to 22, to 22 to 26, to 26 to 30, to 30 to 34. Got it now? F O number of days is 15, 37, 86, 164 and 28. Now we have arranged the line of the vertical column. Next, the formula to find out the model class. First we need to find out model class, then we can find out the exact mode between that model class, right? Yes. Now, formula to find out the model class is model class is equal to size of highest frequency. The size of highest frequency is compared to all the frequency, which is the highest frequency of 164. Size of 164 will be the model class. The size of 164 corresponding class will be the model class. Then which is the corresponding class of this is 226 to 230. 226 to 230 will be the model class. After finding this, we need to apply one more formula, that is mode is equal to L plus, what is the formula? D1 divided by D1 plus D2 into I. Here D1 means, before finding that, we need to give model class frequency as a F naught. Model class frequency we will call it as a F naught, and your model class frequency preceding will be called it as a F1. Model class frequency succeeding will be called it as a F2. First we need to do this. Then after that we need to find out D1. D1 formula is F0 minus F1. Here F0 means 164 minus 86. 164 minus 86, how much? 78. Then D2 we need to find out F0 minus F2. F0 is 164 minus F2 is 28. Here 136 will be the D2 value. 136 will be the D2 value. Got it? Now we have got it, D1 and D2. How to get D1 value and D2 value? By Here F0 means frequency of model class, F1 means frequency receiving to the model class. Subtracting these two will be get D1, and D2 means frequency of model class minus frequency of succeeding to the model class. Then subtracting these two values we will get D2. Got it right? Then after finding D1 and D2 we can directly apply to a formula. Then N means which is the lower class limit of this class, 226 to 230. Here 226 is the lower limit of this class, right? Then 226 plus D1 is how much? 78. Sorry. 226 plus 78 divided by 78 minus 136 into I. Here I means size of class interval. 226 to 230. What is the difference? What is the size of class interval? 4. Or else simply we can apply to a formula. Upper class limit minus lower class limit. 130 minus 126 if we do, we get 4 as a size of class interval. Now we simplify this. 226 plus 78 divided by 78 plus, plus we need to 78 plus 136. How much? 78 plus 136 will be 214 into 4 we need to do. Now come here, mode is equal to 226 plus 78. 78 divided by 214 if you do, you will get answer that is 0.364 into 4. Now x lambda is equal to 226 plus 0.364 into 4 if you do, you will get 1.457. Then answer will be 226 plus 1.457 is 227.457. This will be the answer. Now the answer is between 226 to 230. Exact value we have pointed right now. This is what mode in this data. Got it now? This is all the types of averages to measure the central tendency. Central tendency or average means finding the single value to represent the whole data. Okay? And we have already discussed all three types of averages. One is arithmetic mean, median and mode. Got it? Just work out this most important question in the part A, and all most of the practical questions used to arise from this particular chapter. And one more important topic we need to discuss in the chapter, that is the relative position of mean, median, mode. Okay, that we will discuss. Before that, I hope you have understood all these concepts of the mean, median and mode. How to calculate mean, median, mode with the different types of datas. Okay, so I hope you understood. Then we'll move to the next simple concept of this chapter, that is relative position of the mean, median, mode. relative position, because all these three are measures of average, are measures of central tendency, right? Then what will be the relationship between these three statistical tools that we are going to discuss now? Relative position of arithmetic mean, median, and mode. This is how. Now, suppose if we are expressing, we can express mean, median, mode with a different identical, leads. But now, suppose we express arithmetic mean in form of x bar. Okay. Next, median as a x lambda and mode as a x hat. Got it? Now we are going to express arithmetic mean as a x bar, median as a x lambda, and mode as a x hat. Then we will find the relationship between these three. First, you need to know arithmetic mean means adding up all the values of the observation and dividing by number of items. Got it? And median means the exact central value or middle element will be called it as a median, and the position of median will divide the entire data as a two parts. Okay, entire data as a two parts because it will be the center or exact middle value. That's how it's going to be divides the entire data into a two parts, and this is also called as positional value. Then mode means value which appears more frequently than the other in the data. Okay, mode means the frequency which going to be appear more number of times. Got it? This is what the mode. Here it will be affected by extreme item. It won't be affected by extreme item. It will be appearing more number of times. Mode means appearing the more number of times. Got it? Then now we will discuss what will be the relative position of the mode. The relative position of the mode is, mean median mode is arithmetic mean will be always more than median. Median will be always more than mode. Got it? Arithmetic mean will be always more than median. Median will be always more than mode. Or else we can express in another type. What is that? Always mode will be less than median, and median will be always less than mean. Got it? These two are same, but we are expressing in different form. Mean will be always more than median will be always more than mode, or mode will be always less than median will be always less than mean. Means arithmetic mean. Here you need to observe one thing in this relationship or the relative position of this three. In that, see here, always median will be having in between the mean and mode. The position of median will be always between the mean and mode. In between the arithmetic mean and mode. Got it? down in the sentence, they will ask for 1 mark. Okay, what is the position of median compared to mean and mode? Then the position of median is always between arithmetic mean and mode. It will be always between mode and median. Whether it is less than or more than, it will be lies between these two numbers. Two expressions. One is mean and mode. Always median position will be center of this two. Got it? This is what the chapter 5, that is basis of central tendency. This is the most important chapter of this part A, that is statistics for economics. And this is important nearly for the 22 marks. And next, one more chapter we have in this part A, because due to the COVID-19, the government PU board have decided to cut off the portions of this first PUC. In that way, after the 5th chapter, we are going to discuss one more chapter in the part A, that is index number. That is the last chapter in the part A, index number, and that we are going to discuss from the next session onwards. And after completion of this particular chapter, maybe the part A will be going to end, and we can start with the part B, that is Indian economic development. In that particular part, even we have nearly 10 chapters earlier. Now the government have cut off this chapters, and there we have same 6 chapters in the part B also. Now part A we have 6 chapters, and part B we have 6 chapter. Now 5th chapter we have completed, and after this 5th chapter we are going to move the 6th chapter, that is index number. After completion of that, we will move to the part B, that is Indian economic development. I hope you understood the structure of the economics first POC. Next class will be with the one more new concept. Thank you everyone.